The boost converter is a type of DC-DC converter that steps up a lower voltage to a higher voltage. So in this video, we're going to be taking a look at an example of a boost converter in action, basically. I think that'll really help us further develop our understanding of how they actually work. So this is part 2 of a like little video series I did on how boost converters work. So if you haven't seen part 1, that'll be linked in the description. And I definitely recommend checking out part 1 because it's I think you kind of want to watch both of them to fully understand how a boost converter works. So before we go any further, please drop a like for me on this video. It helps my channel out a ton. And if you'd like to see more videos about like electrical engineering, PCB layout, PCB design, and circuit design, then hit the subscribe button and you'll get a lot of those in your feed. I'd highly recommend watching this entire video from beginning to end. That way you don't miss any important details. And with that out of the way, we can just jump right into it. So here I have a little example drawn out for us. So let's say we have a 5-volt voltage source and we want to step it up to 24 volts. That means across our resistor, our load resistor, we want to get 24 volts across it, right? So the VRL needs to equal 24 volts. So what I've kind of done is I have the same exact circuit, but I just took little snapshots of it at different points in time. So I have it at 0 microseconds, 5 microseconds, and 24 microseconds. So that way we can kind of when we take a snapshot, we're going to look at the entire circuit and see what's going on. And I think this will really help us develop our understanding of how they work. So some of the important annotations I've made to this circuit are we have the current through the inductor as IL1. We have the current through the load as IRL. Then we have the voltage drop across our load as VRL. And then we just have the time that the switch has been closed as T and microseconds. Then we have our voltage source, right? So just looking at it at 0 microseconds. So let's say the switch is, and let's assume that this is at turn on, right? So this has not been hooked up for any amount of time. So that means there's no, like 5 volts is not being dropped across our resistor yet, because this is literally like the circuit just poofed into existence like at 0 seconds ago, right? So the important notes I want to make is that the voltage that forms VRL as a result of IL1 is equal to IL1 times RL. And this is kind of a key concept, I think, for this little video is we're going to look at things in what I would say a current-centric point of view, because while we understand that a boost converter, we're supposed to get a voltage step up, I don't think it's very helpful to look at it and understand like how we're not really taking a 5-volt voltage and stepping it up to 24 volts. I'd rather look at it in terms of what we're doing with the current through this circuit, because the reason for that is inductors operate from a basis of current, right? They resist changes in current, not necessarily changes in voltage. They will happily change their voltage in order to keep current the same. So that's like a key thing that I want to hit on throughout this video. So a couple other notes I have here are, if we're trying to achieve a 24 volt voltage drop across our load resistor, then if the load resistor is equal to 10 ohms, that means we're going to have 2.4 amps flowing through our load resistor, right? This is how much current we need to generate. The other thing I want to note is that at 5 volts and 10 ohms, we will only, with our current setup, right? If we had no inductor or anything, as it stands, our voltage source is only able to supply 0.5 amps of current through our load resistor. So like this is how much we can generate with just our voltage source, no inductor, right? So just going on, let's just take a look at the circuit now 5 microseconds after the switch has been closed, right? So after it's been closed for 5 microseconds, let's say we have 100 milliamps, and this should probably say 1 microsecond just for clarity. That way, if it just make that 1 microsecond. So after 1 microsecond, let's just say that there is 100 milliamps of current flowing through the inductor. Now, since this switch is closed, all of the current path, and we checked this out in the previous video, when the switch is closed, the current is only looping through this section of our circuit, right? So there's actually, like, when I say IL1 equals IRL, that is true whenever the switch, if the switch were to open after 1 microsecond of being closed, that is when those two currents would equal each other. So that's what I mean by that. But let's say, what I'm trying to get across is, let's say after 1 microsecond, the current has gone from 0 amps all the way up to 100 milliamps. So the current is ramping up through the inductor, as I kind of mentioned in the previous part 1 video. So if the switch opens again after 1 microsecond, that means IL1 is going to equal to I sub RL, and the voltage drop across the load resistor as a result of the current through the inductor is going to be 0.1 amps times 10 ohms is going to equal to 1 volt, right? So VRL equals 1 volt after 1 microsecond, right? So hopefully that kind of makes sense. And again, our target is still 2.4 amps, right? So then let's just skip all the way ahead to looking at it 24 microseconds later. We have built up, the current has ramped all the way up to 2.4 amps of current through the inductor, right? And again, we're still only looping through this little section of the circuit. And then let's say the switch opens at 24 microseconds. Then all of this 2.4 amps of current is going to be distributed or carried all the way over to our IRL, right? IRL is going to equal IL1. So after the switch is open, we're going to have 2.4 amps of current flowing through our load resistor, which is what we need, right? Because 2.4 amps times 10 ohms equals 24 volts, right? So hopefully that kind of makes sense. That's how we get to 24 volts, right? That's kind of, in a nutshell, that is what's going on. So hopefully that makes like a lot of sense to you, and understanding that, like, what we're doing is we're using the fact that the current, like, so if we left the switch closed for an indefinite amount of time, I mean, the current would just ramp up forever, right? It would go up to 100 amps, infinity amps, right? And that's like kind of the key that we're taking advantage of, is that this inductor allows us to ramp the current up with whatever voltage source we have, right? Like the beauty of it is, this voltage source could be 10 volts, it could be 1 volt, it could be 100 millivolts. After a certain amount of time, the current through the inductor would eventually reach 2.4 amps. And then we could transition it to this load, right? So you can effectively boost the voltage up to and this is with ideal circuit elements, but you could effectively boost the voltage to whatever you want it to be, right? So that's kind of the key concept that I want to iterate here, is that if you look at it from a current-centric point of view, I think it makes a little bit more sense of how exactly the boosting happens. And it happens because, like I mentioned, inductors will happily change their voltage in order to maintain a constant current, right? And that's what this inductor is trying to do, is saying, okay, I know that I had basically no resistance here to be pushing my 2.4 amps through, but now I have 10 ohms of resistance, so I gotta up my voltage in order to do that. And so the inductor just happily does that, and we get what we want out of it, right? So hopefully that made perfect sense to you. If you have any questions regarding this, drop a comment and I will be happy to answer it. If it's a big enough question, I will just make an entire dedicated video about it. And that's pretty much all I wanted to cover in this video. So I hope this example really helped illustrate what is going on in actuality in terms of how the operation of the boost converter works. So yeah, if you made it to the end of this video, thank you so much. I really appreciate it. And hopefully I will see you in the next one.